Welcome back to another video. Today you're watching HVAC tips for technicians. I am Tad, and I'm going to be teaching you more about gas heat and how to troubleshoot and diagnose problems with this 12.5 ton package gas unit behind me, made by American Standard. Today we're going to be going over issues like having a bad hot surface igniter, what that looks like, how do you check it, know if it's bad, and then the inducer motor assembly I just replaced. I'm going to go over why that was bad, how I knew that was the problem. And then if you've got any questions, put those in the comments. Before we start, drop in the comment down below where you're from and who you are. I want to know who you are. And definitely before we forget, we've got to subscribe, we've got to like, we've got to comment, but we've got to hit the notification bell as well. So hit that bell, ding, so you know what I'm doing in the future. Definitely check out the playlist though as well. To all my members, before we start, thank you so much. For those of you that need tech support, and you're reaching out to me, and then I'm just telling you, hey, be a member, join, I'll send you my email, I'll give you my phone number, then we can make contact and I can help you through your issues. Thank you so much to all those members. To the members that don't need anything but just support me regularly, thank you so much. To my subscribers, I love you. Let's go ahead and let's stop wasting time. Let's get to today's video, learn more about gas heat, the process of elimination, figuring out the sequence of operation and what happens first and why we had a bad inducer motor and a hot surface igniter. Let's go. All right, first I'm gonna give you the overview, right? We gotta go over the overview. So this right here is where the 24 volt connections come in. We've got our red, yellow, so we got our Y1, W1, this is our call for heat. We got G, W2, which is second stage heat if you got it, Y2, second stage cooling. This right here is where our low voltage thermostat wiring comes into our package unit. Okay, we got transformers, we got two contactors for our compressors, contactor for our indoor fan. This right here is the relay for our outdoor fan. This is a 9340. This is the ignition control board, and it was replaced because there was some burn marks up here on the, I went ahead and got a new board. But the problem I was having was this right here is what outputs voltage to that inducer motor, okay? And the inducer motor's right here, the new one. And I don't have it plugged up yet because I was reading ohms on the new one versus the old one. And that's how I figured out that I had a bad motor. You see this purple wire and this black wire has 240 volts applied to it. And this motor is supposed to come on when the voltage is applied. But it wasn't doing anything. It wasn't making any noise. I checked and made sure that the wheel could turn easily and that it wasn't the bearings, but if it had a problem starting, it would probably be very, very hot because voltage is applied, it's trying to turn, but it's not. It wasn't doing anything. So I was like, what is going on with this thing? I got power to my hot surface igniter, but it didn't actually glow. I could tell it wasn't glowing because there's a little sight glass in here where you can see inside the actual chamber where you have your flame created, where you have your hot surface igniter glowing. So I couldn't see it glowing, and I had 120 volts, and this right here is the plug that comes from the ignition control board here, right there, ignition control board. This right here is the plug that goes to the hot surface igniter, and I checked across the plug and there was not 120 volts. Now I'm going to show you 120 volts and show you the bad hot surface igniter. But first, I'm going to show you this motor. This is the old motor, spins just fine. So how do I know the motor's bad, the old motor? So what I did was I took my meter, I put it on ohms, and I decided to measure the lines. So the line connection for these windings is black and purple. Okay, and I'll show you that on the diagram. But black and purple, I got my leads in there, and it's OL. We're not measuring resistance. That means our windings are open for the motor, and even though we have power going to the motor's not spinning because we have an open circuit. So now I'm going to show you the new motor, and we're going to measure the resistance for the windings of the new motor. All right, new motor line, which is purple and black, meter on ohms, 63. So we're measuring resistance. This motor's good. Now I'm going to show you when I turn the power on. I've got, because I don't have no access to the inside right now, I've got W1 and red jumped together right here, so it'll call for heating. I'm going to go ahead and let it call for heating, and I'm going to show you the inputs from the board, actually outputs to the loads, the two different loads, which is the hot surface igniter and then the inducer motor. And then I'm going to show you plugged up to this motor, it doesn't run, plugged up to this motor, it does. Then we're going to talk about the sequence of operations. What comes first? All right, so we got a call for heat. First thing that should happen is our inducer assembly should come on. And we've got 247 volts coming out of the plug that comes from the board and goes to the inducer assembly. So now that we know we have voltage, we should plug it in and see if it works. So you can hear the motor running that's plugged in. I'm going to plug it into the old motor and show you what it was doing. All right, this is the old motor. You can see it is plugged in now and it's doing nothing. So the only way you would know this motor is bad, because usually these inducer assemblies, the wheels are burned up, not on these models, but on residential models especially, your inducer assembly housing is made out of a little bit, I think, thinner material than this, and it's rusted through and you can tell it's bad. But this, you need to use your meter. You need to ohm the windings. If you go get an OL reading and you're not reading resistance, you have an open circuit. Boom. All right, now let's go ahead and check our plug that goes to our hot surface igniter. We went ahead and put a new hot surface igniter in, and you can see there's some RTV silicone. That's another thing you need to know about. High temp red RTV silicone. This is great for making a gasket. Sometimes you have to use this in the field, but remember, it's got a 12-hour, 24-hour wait for curing. So keep that in mind. You may have to come back to the job. Most inducer assemblies come with a gasket. This right here is a different gasket than residential. Of course, some of them are rubber, some of them are not rubber. They're type of cloth material, so you might need this in the field. All right, let's go ahead and take a look at the hot surface igniter. The voltage coming from our board should be 120. All right, so we're checking the plug to the hot surface igniter. Got 130 volts. That's exactly what we need. I'm going to show you the old hot surface igniter and show you what it looks like when voltage is applied to a bad hot surface igniter. So this is the bad hot surface igniter. We've got it plugged up, and you can see it's got a little glow, but it's got a crack. See where that crack is? Now let me take this apart and then show you how I know this is bad. You can see it's not really glowing because there's a crack in it, but I'll show you the crack when I take the power loose from the hot surface igniter. Oh, this right here is the bad hot surface igniter. That little area right there is the part that's damaged. That's what's keeping this from operating properly. So we've got a new hot surface igniter now, and it doesn't have this white spot and it doesn't have this crack. So these are easily damaged, by the way. Be very careful when you install a hot surface igniter. If you touch this, I mean, it'll just break so easily. So let's go ahead and plug in the new hot surface igniter and watch the glow. All right, so we're fixing to call for heating. I've got my leads measuring the voltage to the coil of the gas valve. Process, now sequence of operations. So inducer motor comes on. After the inducer motor comes on, then you have all the safeties. Usually on residential equipment, you have a pressure switch. On this unit, you do not. So you've also got a rollout switch, a detects flame rollout. You've got a limit switch, and there's one in this cabinet over here, and that is just in case you have a high temperature situation. Limit switch breaks open, indoor fan stays running. Keep that in mind. So right now we've got the inducer motor running. We should see some glow once we have power to our hot surface igniter, because that's what happens before the gas valve gets its power. You have inducer motor, hot surface igniter, well, inducer motor, safeties, hot surface igniter, and then gas valve. Oh man, we got a lot of rust blow out of there. So, couldn't really see the glow, but it's definitely working because it's lit. Gas valve's got 27 volts. So we got the voltage we need. So to replace the inducer assembly, I just wanted to go over the steps used to replace this. It's super easy. All you have is these bolts, and you have 1, 2, 3, 4, 5, 6 bolts, it looks like. So you just take this, and then you have 4 bolts, 1, 2, 3, 4 right there. I actually use my drill and a socket and a bit that connects the two. And this right here will come right off, Then you have this disc, and you have a gasket that goes on the disc before you put the actual housing with the inducer motor onto the disc. So you got to make sure to have that gasket in place. Wanted to go over that real quick. So I hope you learned something in today's video. Right now we're fixing to go over what I usually find wrong with these gas package units every year during the winter, summer, just in general. We're going to talk about that. But first, just basic overview. Today we went over how to diagnose a hot surface igniter and then an inducer motor, and we talked about a few things I run into in the field with those two components. We went over how to use your meter, and that was great. Hope you learned something. Definitely leave a comment below. Now let's go over what I find in the field wrong with these types of systems, then we'll conclude the video. So what do I find wrong with these systems that's super common? Right here's the panel for the indoor motor, and you're going to find belts or something that had to be tightened on a regular or replaced due to wear and tear, run time. This right here, this panel is to take off the panel for the filters, because right here is the indoor coil that's slanted this way, and you have to replace filters on a regular. So that right there is in that panel. Okay, hot surface igniter, something that goes bad regularly. Gas valve, you'll have voltage, but you won't have any gas. How do you know? You check the outlet and the inlet. If you got inlet pressure and you don't have outlet and you got 24 volts, your gas valve's bad. You have burners that need to be cleaned on residential equipment, flame sensors. This equipment's a little bit different, so we got a little less maintenance with the heat side there. We have got busted heat exchangers, which cause rollout switches to basically trip. So if you have a rollout switch, you need to check the heat exchanger. All right, what else we run into? We run into bad contactors where you don't have voltage coming from the line side to the load side. So you check voltage input, it's there. This right here is closed, but you don't have voltage coming out. So that's something that goes bad. Low on refrigerant, how do you know that? Put your gauges on it. You wanna know how to check superheat and subcooling? Go check out my video, how to charge. I have a very good video on checking superheat and subcooling. You run into bad boards. How do you know a board's bad? You have input, but you don't have an output. That's an easy way to know. So you check voltage, you got voltage in, but no voltage out. I've had these boards go bad as well. The way you know they're bad, they're burnt. The LED light won't come on. You don't have your outputs, but you got your inputs. These relays go bad. Outdoor fan motors, you have bad bearings. How do you check bearings? Check out my videos. I've got tons of videos. Dirty coils. Dirty outdoor coil causes high head pressure. Dirty indoor coil during the cooling causes low suction pressure. So you got to make sure your coil's not froze before you start adding refrigerant. So definitely keep that in mind. Oh, that's a few tips. I really hope that you liked the video. And also, you could have a bad thermostat or a bad thermostat wire. How do you know? Well, you could have a short, 24 volt short that's tripping this little resettable here, because this is where our 24 volts is. This is our transformer. Bad thermostat, it's just not closing, you know, red to yellow or red to green, and it's not basically sending power to the board. So that's something that could be bad as well. Bad capacitors. How do you know? They're exploded out the top, or they don't have a microfarad reading that's up to par with what the manufacturer, well, what the specs are saying it should be. All right, I think that's it. Also, dirt daubers can clog up the flue, so that's something that can happen. More on other types of units, not so much on this. We got really good screens on here, so, but they can get in the inducer motor, not in this one, but in other types of unit. I hope you enjoyed today's video. I hope you learned something. Definitely let me know who you are, where you're from, and definitely send me a like. I really appreciate those likes, the subscribes. Thank you so much, everybody that watches my videos. I'm Tad. You've been watching HVAC Tips for Technicians, and don't forget, I'll keep you cool if you let me.